When you're done, you can bring it up to me, please. Let's just set them right here on my desk, please. Okay, thank you. Yeah, sure. You know where it is? Just go down the hallway to the left and then that way.
Professor, accidentally, instead of doing it by 2, by 3, I did it by 2. Can I
Here.
quickly redo it?
We'll go do it on a separate piece of paper then.
Okay.
Yeah, so we don't have to waste time doing this. Okay. All right, thank you. Did you do it here? Did you do it in your homework? Okay, just copy. Yeah, just copy. Oh, you did it by 2 on the homework. Got you. Okay, thank you. Okay, anybody else? Thank you. All right, is there anybody else? Okay, so we still have a little bit of time. All right, so let's get started. Just turn that in when you're done, okay? All right, so a few administrative things first. The video from last class, I just posted that last night. I didn't get around to it, not to get into too much detail, but on Thursday, right, we had class, and I had a class immediately after. So in the middle of that class, I got a call from my wife that our dog we had to go to the vet and we had to put him down. So it was like not a good day, right? So it's been kind of a rough patch here for us. How many of you have had to put a dog down? It sucks, right? They're better than people most of the time, right? Your dogs. So anyways, when I was in the middle of class, I just ran to my office, I threw all my stuff in there, and I left. So remember how I told you I was going to update the roster? I didn't do that yet. So I will, and I will still pass this around today. So I just want to let you all know that's why the video took so long. That's why this is not updated. This video will be posted today. So, all right, so let's get into today's material. We're really continuing from last time, and this is more review. So we stopped at what, number 15? Is that what we stopped at? Okay, so what I'm going to do now is problem number 28. And it's going to be more simplification. These are rational expressions, so 12x over, I'm not talking about the quiz because it was a homework problem, so you should have been okay in a perfect world. Let's see, x squared minus 16. All right, it's a good problem here because this makes sure we understand a few things. So first thing, and this is going to come up in calculus a lot, is you're going to have a fraction over a fraction, right? anytime you have a fraction over a fraction, you have to know where the big division bar is. So you see this division bar is bigger than the others. That's intentional. Because if I wrote something like this, 12 divided by 6 divided by 3, what is that? Right? If I make these bars the same width, what's the answer to that? Well, one person might say, do that first, right? What's 12 divided by 6? 2, and then 2 divided by 3 would be 2/3, right? But then someone else might do what? 6 divided by 3, which is 2, right? And then 12 divided by 2 would be 6. So which one is it? Can't be both, right? So whenever we write, these are called complex fractions, you have to make sure one of the division bars needs to be bigger than the others so that you know what to do first. So if I did this, like this, then that would tell me do this one first, okay? So that's a little side note. So how do we do division of fractions? Well, division, back when you're learning about fractions, division is the same as multiplication of the reciprocal. So this is the same as leaving this fraction alone, a over b, right? And then multiplying by the reciprocal of this fraction, d over c. Okay, that's something that you should be very comfortable with, right, as you move ahead, because you'll see this a lot, like I said, in calculus, these complex fractions. So what I'm going to do here to start the problem is I'm going to rewrite it like this. 12x over 5x plus 20 times x squared minus 16 over 4x squared. So that's basically that property. Does everyone see that this is that property right there? I'm leaving this fraction alone, right? Then I'm taking this fraction and I'm flipping it over and I'm multiplying. Are we all okay with that, or do we need to go into detail about that at all? Can we? Yeah, we're good? Okay, so now at this point, what I'd like to do is try and simplify this. So I'm going to look to see if I can factor anything, right? So I have to recognize, first of all, that this is a difference of squares, right? That's a difference of squares. So I can factor that. 12x, I didn't bother looking at that because there's nothing I can do with 12x. 4x squared, nothing I can do with that. Is there anything I can do with 5x plus 20? Factor out of 5, right? That's called a GCF, right? You can pull out a common factor, greatest common factor. So here I can pull a GCF. So I'm going to do that. That's going to be my next line. 12x over, pull the 5 out, you get x plus 4. And then times on top, that difference of squares is x plus 4 times x minus 4. And then over 4x squared. So if you're not sure why this becomes this, that's where you'll need to come talk with me, make sure we can, be good on this, difference of squares. It's something I expect that you have seen and are comfortable with. All right, at this point, I'm allowed to cancel factors. So I see here with multiplication, because there's multiplication through everything, anything that's common to the top can be canceled with the bottom. Now, remember last class I said this is where you have to do that little asterisk and say, I promise, blah, blah, blah. That'll come later in calculus, but for now, let's just cancel and keep going. Anything else I can cancel or reduce? It's actually called reducing, but most of the time when you're in middle school, high school, they say cancel, so I'm just going to use that same terminology here. But we're really reducing the fraction. That's what we're doing. So this, what else? The 12 and the 4, right? Those can reduce. 4 goes into 4 one time. 4 goes into 12 3 times, right? So you can reduce that. Anything else?
You leave the x now.
Say again?
You leave the, since it's an x and an x squared, you just leave one x now.
Okay, so we're going to cancel one of the factors of x here, right? This is really like x times x. So I'm going to get rid of this x, right? And get rid of one of these, which would make that a 1 up there, right? Okay. So anything else that goes away? What's left on top? This and this, right? So I'm just going to put that 3. I'm going to leave it just like it is. And then on the bottom, I'm left with a 5, a 1, and an x. So just 5x. 5 times 1 times x. There you go. That makes sense? Would it be wrong for me to distribute the 3 through? No. Okay, it's okay. Both those answers would be acceptable. All right, we're going to move on. Okay, the next one is just horrific looking. Number 36. So we've got 9x squared plus 3x minus 2. 9x squared minus 3x, plus 3x, sorry, minus 2. That would have been bad. And then over 12x squared plus 5x. Does it feel like a super Monday right now? Am I the only one who's just like... But we're here, we're doing some math. That should make you feel good, right? That should get you... No?
Yes.
Let's see, minus 10x, and then minus 3. Okay, there we go. Nasty, right? That just looks terrible. All right, so let's do that same thing that I did a second ago with that property. I'm going to keep the top fraction, and I'm going to change it to multiplication and flip the second one over. In my lower algebra classes, we use this thing, this little saying that kind of helps them remember. Keep, right? Keep that one. So we say keep dot flip. Keep dot flip. You may have heard that before. So we're going to keep that one. We're going to put a dot, and then we're going to flip the second one over. All right, that's just me rewriting it. Okay, now at this point, I have to see if I can do any factoring. And there is a ton of factoring here. Every single one of these, this one, this one, this one, this one, all factor, and they all are going to require like the AC method or the guess and check that we did in class last time, right? So let's do one of them. I'm only going to do one in detail. The rest I'm just going to say, yeah, we would do the same way. Okay, so which one do y'all want? Top left, top right, bottom left, bottom right. Which one do you want me to do? You want to do top left? Okay, let's do top left. Okay, I'm going to do that over here. This is like scratch work on the side. Try and do 9x squared plus 3x minus 2. Let's see if we can remember the method that I taught you or showed you. We said we would take the number in front here, 9, the number in the back here, negative 2. We would multiply those two together, and we get negative 18. We put that in this little x thing, and then we take the number in front of the x right there, positive 3, we put it here. And then we say, okay, we have to come up with two numbers that multiply to be negative 18, but add up to be 3. So you sit there and you mess around in your calculator or whatever it is, right? And you finally come up with 6 and negative 3. 6 and negative 3. Okay, these two numbers multiply to be that and add up to be this. Now the next critical step. Two sets of parentheses, right? You put your variable, x, leave a space in front of those x's. Then you put these two numbers, right? Plus 6, minus 3. Almost there. What's this big step right now? Divide both of these numbers by 9. This number right here. Divide by 9. I said don't ask me why, right? Just do it. Just do it. And now what? Reduce those fractions if you can. So do these fractions reduce? Let's see, 3 goes into both of those, right? So 2/3 there. And then over here, 3 goes in both of those, so 1/3, right? Almost there. There's one more thing we had to do. What was it? If you have a fraction, right? We have fractions, those numbers, 2/3 minus 1/3. What do we have to do? Take the numbers that are on the bottom, the denominators, and do what with them? Swing them up in front of the x's. So take this 3, swing it here. Take this 3, swing it here. And then what you get here is 3x plus, now we swung the 3 out, so we have a 2 here. Take this 3, swing it in front, 3x minus, and then we took the 3 away, so we have 1. That's it right there. Y'all follow? Let's just double check that this worked. What's 3x times 3x? 9x squared. Okay, good, right? Okay, what's 3x times negative 1? Negative 3x. Okay, what's 2x, positive 2x times 3x? I'm sorry, positive 2 times 3x. 6x, so plus 6x. And those add together to become 3x, which is this. And then 2 times negative 1 is negative 2. So it works, all right, in case we had any doubts. So that's the top left. We have to do that 3 more times, right? So I'm not going to show that. I'm just going to do it. So it's 3x plus 2, and then 3x minus 1 over, okay, this one, yeah, I don't know if I'm going to be able to do that one quickly. Guess and check, that might be hard for me to do, actually. So let's see if we can do it. Let's see if we can do it quickly, all right? Let's try real fast to see if we can do that same thing without me saying as much and writing as much, okay? So I'm going to take, what's my x look like over here? What's on top? Careful. Negative 24, and then 5, right? So this times this, negative 24, then that number. Okay, 2 numbers multiply to be negative 12 and negative 24, and multiply to be, multiply to be negative 24, add up to be 5, would be?
8 and negative 3.
8 and negative 3. That's going to take a different amount of time for every one of you in here, right? Some people are going to see it right away. Some people are going to have to mess around with their calculators, right? And now, let me see. I'm going to do x plus 8, x minus 3. What do I still need to do? Put the number in front. 12 underneath those. Reduce these. 4 goes into that, so 2/3. X, 3 goes into that, 1/4. So I'm going quickly here, right? I'm moving fast. Now bring the numbers up front. So we're going to have 3x, that 3 is coming here, plus 2. And the other one, 4x minus 1 times. Now we go again, right? Am I moving too fast?
No.
I mean, do you know what I'm doing? I mean, like if you had more time, you could do it, yes?
Yeah.
Okay.
I'm starting to get it.
Starting to get it? Well, let's see if we can do this one. I'll do this one right here. I'm going to do this one right here. Okay, so what goes in that little x? Negative 24 again, because you're doing 8 times negative 3, and then this time negative 10. All right, no one give the answer yet. Raise your hand when you have the 2 numbers. Raise your hand when you have the 2 numbers that multiply to be negative 24 and add up to be negative 10. So 2, 3, 4, 5, 6, 7, 8. 9. You can put your hand down. 9 of you have it? 10? Was that it? No? You thinking? You got it? 10? 11? You can put your hand down. You're good. I think that's about half of you. Right? That works. Like I said, it's going to take everyone here a different amount of time to do that step. So now I come here, x minus 12, x plus 2. Take the number that was out front, which was an 8 this time, put it underneath both of these. Reduce the fractions. 4 goes into both of those. 3 over 2 this time, and then over here, 2 goes into both of those, so 1/4. And then swing our fractions out front. I'll put that here. Or swing the denominators out front is what I should be saying. I mean, this is a great problem for a test, right? Like this, make sure you know how to factor. Well, make sure you know how to do the AC method. Yes? Good? Okay, make sure I copied it down right. Did I copy it down right? Yes. All right, last one. This one, I'm not going to show the work. I'm going to kind of guess and see. I'm going to think it's 3x, 3x. Is that going to work? minus 1 minus 1. I think that works. Yeah, that does work. 9x squared minus 3x minus 3x minus 6x, negative 1 is plus 1. So that was me guess checking in my head. But you could do it the same way over here, right? You can do it the same way. Yes?
Why did you get the negative 3 over 2 underneath the negative 12?
So I asked myself, does this reduce, right? So what number goes into both of these, right? So 4 goes into both. So 4 goes in here. 12 divided by 4 is 3, right? And then, is that what you're saying?
Yes.
Yes, okay. And then there. Yes?
Does the AC word method work every time?
Well, not every quadratic can be factored. So not it
For the ones that can't be factored.
for the ones that can be factored over the rational numbers, which means if your factor contains a fraction in it, then yes, it would work if it's factorable.
Okay.
Yeah. And now if it's not factorable, we have other techniques which we'll get into in this class. All right, there we go. Now you may reduce. Anything that's common to the top and bottom can go away. So gone, 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 gone. That's it. That's all I can do. These are almost the same, right? These are almost the same, but remember, in order that we talked about last time, there was a tricky thing you could do by pulling a negative 1 out and getting things to cancel. That only works if they are exactly opposite from one another. See, this is positive 4x, they're the same, right? This part's the part that's different. You need them both to be opposite. So if this is 4x, I'd need that to be negative 4x. This be negative 1, that would have to be positive 1. If that was the case, then you could pull a negative and cancel. But since they're not, I just leave it. So my final answer is going to be these two on top of these two. And that's it. We're done. Okay, we good? Or not good? I mean, you with me? So remember, we're reviewing, right? This is still review. So this is the expectation is that you've seen some of this at some point and that you can get back up to speed where you're comfortable doing this. All right, I'm going to do 44. So 5x minus 4 over 3x plus 4. And then in between those, I have a subtraction symbol. That's the first time we've seen this. And then x plus 1 over, and then 3x plus 4. All right, so in the two problems that I've done before this, we were doing division, right? Weren't we? It was a fraction over a fraction. That's division. Now what we have here is subtraction, right? We have subtraction between two rational expressions. So you have to go back to when you were learning about fractions and how you add and subtract fractions, right? So if I have, let's go back to the good old days. If I have 3/4 minus 1/4, right, can I subtract those two right now? Why am I allowed to? Because they have the same denominator, right? And when you have this, what you do is you leave the denominator alone, right? And then you just do 3 and you take away the 1. 3 minus 1 is 2. 2 over 4 could reduce, right? 2 goes into both of those. That's how we do subtraction when we have the same denominator, right? We have the same denominator here, don't we? So we can just use that. So I'm going to just say this is equal to, keep the denominator the same, and then be real careful here. We have to take this and subtract this, right? One of the biggest problems for students in algebra is the proper use of parentheses and knowing when to use and when to not use it. So I'm going to play this very safe. I'm going to say I'm taking 5x minus 4 and I'm subtracting from it x plus 1. Do y'all agree that's what I'm about to do? I'm doing this, take away this. Now this is what we started class with last time. We're doing adding and subtracting polynomials. So my first question to you would be, can I just drop the parentheses here? Can I? So I'm hearing yes and no. So someone who says yes, tell me why I can drop it.
There's just a 1 in front of it.
There's a 1 in front of this. And if you distribute that 1 through, it changes nothing, right? Can I drop the parenthesis on this one? No, because there's a negative 1 in front, which has to get distributed through. all right? So if you need to, put a 1 there. If you need to, put a 1 here. So you get 5x minus 4, then minus x minus 1, all over 3x plus 4. Do y'all see why it's minus x minus 1? Right? This negative must go through. Now in the numerator, collect like terms. So 5x, put that together with minus x, and you get 4x. And then minus 4 minus 1 is minus 5. And then all over 3x plus 4. All right, there we go. That's your answer. Can we cancel these x's? No. You can only do that canceling or reducing when there's multiplication between things, not addition and subtraction. So that is our final answer. This is the most common mistake I see students do. Right? That's the most common mistake I see. They say, okay, I'm subtracting these two. They have the same denominator. They put the denominator down there. Then they do 5x minus 4 minus x plus 1. They just write it out like that. And it's wrong, right? It's wrong because this subtraction did not get applied to the whole numerator. The subtraction only got applied to that x right there, right? Never got applied to the 1. So just be careful, right? All right, may I erase? Get the next one. You know what? There's none here that have different denominators. Let's do one that has different denominators, because we're going to have to do it in another problem anyway. Let's do 50. 3x over x minus 4 plus
48 has different denominators. Negative.
48. Yeah, it does. I'm going to do 50, but I'm going to change it to a minus instead of a plus, just to make it worse. There we go. All right, so we want to do this. All right, so let's go back again to when we were learning about fractions. What if I do 3/4 take away, let's say 2/5? Can you subtract these right now the way they are? No, what do you have to get? Common denominator, right? This all ringing a bell, yes? So we need a common denominator. So you look at the 4, you look at the 5, and you try and find what we call we say the least common multiple of those two, which we call the least common denominator. So we're looking at all the multiples of 4, all the multiples of 5, and we're trying to figure out a number that exists in both of those lists, right? So you think about all the multiples of 4 are what? 4, 8, 12, right? You list out all the multiples, then you list out all the multiples of 5, 5, 10, 15, 20. Try and find a number that's in both of those lists, which would be 20 is the smallest one, right? So the idea is that we need to turn both of these into 20s, right? And to do that, we're going to use one of the most fundamental and important properties in math, which is that when you multiply something by 1, it changes nothing, right? So we're just going to be clever. We're going to multiply this by 1, and we're going to multiply that by 1, which changes nothing. It's just the way that we write that 1 is not going to be a 1. It's going to be something else. So we write this, 3/4. I needed to turn that 4 into a what? A 20, right? Which means I need to multiply it by 5. But if I multiply the bottom by 5, I must do the top by 5. See, that's a 1, which that means I'm not changing anything there. It just looks different. And then I do the same thing on the other one. So instead of 1, I put, let's see, I need to turn 5 into 20, so I multiply by 4 on top and bottom. Right? That's the way we do this with fractions, right? Now, I'm going to go ahead and do the multiplication. Why am I going to do the multiplication now and not the subtraction? Why am I going to do multiplication before I try and do the subtraction? Order of operations, right? Multiplication comes before subtraction. So we're going to do these multiplications now, right? And let's do those. So how do you multiply fractions? Straight across, right? 15 over 20. So let me continue this up here. This is 15 over 20 minus what? 8 over 20. And now you can put them together, right? They have the same denominators. So you just do 15 take away 8 over 20, which is 7 over 20, right? That's the way we subtract fractions when they don't have the same denominator. So that's something we've done. And this is something we've done, I guess, too. But we're going to do the same method we did there here, right? It's more complicated here, though, because these are variable expressions. So they're not numbers, so you can't come up with a list and try and figure out like what's common in both. So what we do normally is just whatever's here that's not here, we just make it appear, top and bottom. And then whatever is here that's not here, we make it appear on the top and bottom. So I'm going to multiply by 1. Here's the 1, right? This one's going to be x plus 3 over x plus 3. And this one's going to be x minus 4 over x minus 4, right? Those are like those hidden ones that we had here. Same thing, same procedure. Except by doing that, they will both have the same denominators, right? This denominator, when you put this together, will have this times this, and this one over here will have the same thing, which is what we're going for. Okay, let's go ahead and do the multiplication. Just like we did here, we multiplied straight across, straight across, straight across, straight across. We're going to do the same thing. So let me put that. I'm going to do the x plus 3. I need to multiply that times the 3x, and then over the x plus 3 times the x minus 4. Then minus, then I need to take the 2x, multiply it times the x minus 4, and then do the x plus 3 times x minus 4. Right? If I ask you to multiply these two together, you have to put them in parentheses, right? This times this. Same with these two. Here, put in parentheses. Why did I not put the 3x in parentheses? I put the x plus 3 in parentheses. Why did I not put the 3x? See, I didn't put it here. See, I didn't put the 3x in parentheses. Why didn't I do that? It's one term, right? It's one term. So I'm just going to distribute it through to both. I'm going to distribute from the back, which is fine. You don't have to, like here, distributing through, that's distributing through the front, but you can go through the back as well. It's the same thing. So this had 2 terms, so I put in parentheses. This had 1 term, so I did not put in parentheses. All right, here we go. Multiply here and here. So what's 3x times x? 3x squared plus 3x times 3 is 9x all over. Now on the denominator, you could, if you wanted to, FOIL this or expand it, right? You could if you wanted to. I'm going to not do that. I'm just going to leave it. You could if you want, but there's a chance that something might cancel here in a minute, so I'm not going to. So to get 2x squared minus 8x, I just multiplied through there, distributed. And then on the bottom, I'm going to leave it alone.